So thank you, Jan, for the introduction. And indeed, so my talk is titled Creating Lightweight Consistency Checks for Continuous Model-Based Development. And before you now tune out and think like, okay, I'm not doing model-based development, so this is not relevant for me, let me allow me to claim the opposite and say that you probably are doing model-based development, because what we include in model-based development is quite a broad set of things. So you can think of in more kind of formally modeling aspects like a system model or UML models or this kind of thing, all the way to more, let's say, informal architecture diagrams or so on. So even these things can be considered models. The important thing to call something model-based development for our definition is that these models are used as core development artifacts. And by that I mean that they are used throughout development and maintenance of the system to define the system. So they are not kind of one-off, let's say, whiteboard sketches that are created and then forgotten about, but they're really artifacts that are kind of collaboratively and iteratively created and are expected to design the system, but also the system is expected to conform, of course, to those models, to those artifacts. And now already a kind of problem arises, because what we need to maintain, but what is easily lost, is a structural consistency between these artifacts, because you don't have a, let's say, a link. Like if you are doing everything in code, your building tool or your compiler will start to complain when you are referencing something that doesn't exist or something. But if you have these models, let's say quite high level design models or system model, and you have implementation on the other side, it's quite easy to lose a consistency between them and to for example, mis-implementing things in code that you did promise that there would be in the system model, for example. And still, this consistency is quite important, because on one side, of course, you want the implementation to follow the design that you created, obviously. And also, on the other hand, you want that design to accurately document the eventual implementation that is there, so that you can use the models and not have to look in the code when you want to do things like change impact analysis or reuse analysis of certain parts of the code. But I was not only saying model-based development, I was even saying continuous model-based development in the title. And so what do you mean continuous? So what I mean by continuous is I want to emphasize that the let's say iterative development of various artifacts in all phases of development. So I want to offset that to like let's say more gated steps between steps where you're saying, for example, okay, we must finish the requirements entirely before we can continue with the architecture. But instead, of course, all of these phases are kind of iteratively and continuously all the time created. And for one or more of these phases, you are using models, as we discussed before. So now in this kind of setting, this consistency management is a more pressing challenge, even more, because if you always have to do these kind of consistency management manually, then it will slow down those development cycles, because it will cost a lot of effort to do the analysis and so on. On the other hand, if you have a mistake in let's say in the consistency between some artifacts, then since you're continuously developing and iterating over all these artifacts all the time, they are kind of potentially propagated quite quickly to other parts of the system, and you want to kind of prevent that. So the question is then, how can we provide insight into the consistency or inconsistency between various development artifacts? And there I say that there's hope. We can actually benefit more from the models that you are already creating by establishing consistency checks between them and between other artifacts. So here I illustrate again this kind of maybe system model and code, but you can even think of other artifacts as well. You can think of configuration files, interface definitions, whatever you want. So then the question is, what steps can we take towards consistency management and ultimately towards supporting this kind of idea of continuously model-based development of a system? And it depends, of course, on where you start. But let's start in some case where you have maybe informal and disjunct artifacts. And by informal, I mean, for example, you have a drawing, but the drawing does not necessarily conform to a modeling language, or it doesn't necessarily have very strict semantics associated with it. So it's kind of informal artifacts, and it's disjunct in a way that it's not concretely or explicitly linked to another artifact, to an implementation, for example. There's kind of an idea in the minds of the engineers that, of course, we draw here some concept and it must somehow be implemented on the other side, but there's no concrete links between them. So if we start from this phase, then the first step to do is to agree somehow on the semantics of the models or the other informally artifacts such as drawings that are created. Of course, you cannot create a consistency check between a free-form diagram and an implementation, because there's no wrong answer anyway. If you don't define what exactly a concept means on one side, let's say you want to say that a system component in the diagram should be implemented in a system component in the code, without knowing exactly what you mean by the term system component, you cannot do this. So the first step is to define somehow artifacts or the semantics of these things. Then, once we have these, okay, now we have defined clear artifacts, but still they are not connected. So there's no explicit link between things. So they are still in a way disjunct. So then, of course, next step is to link them, to say how can we connect them, and this does not have to be very complicated. It can be as simple as saying, okay, for example, if we think about the system model and code on as the two artifacts that we want to check consistency between, we can say, okay, for example, we say that for every state in a state machine in this system model, there should be a class in the code on the other side. So in this way, you somehow link them. You somehow create a rule or a consistency rule between these artifacts, saying this is what should hold. This is what we must check. Okay, so now that we have them in a way connected, the next step, of course, is then to check the consistency between them. So now what we want to do is we want to establish some kind of automated consistency checks and a visualization of the results that is accessible to the relevant stakeholders, so that they are aware of this inconsistency, and then they can resolve it also. And then we say that, okay, now you are in a continuous MPD ready, by which I mean that, okay, now we have defined and connected the artifacts, and we have created a means to monitor the consistency between them. So now we are ready to iteratively and in short cycles develop all the models and all the other artifacts, because we are sure, or we can monitor that they remain consistent, or if they become inconsistent, we are aware of that and we can resolve them if that is necessary. Okay, so now this is quite high level, but how can we achieve this kind of goal? So I want to go through an example setup that I'm talking all the time already about, this kind of system model and code. So let's take that as the setting and describe how we could establish consistency checks in a lightweight way in this setting. So you have this example setup where you have models on one side, let's say system model, and we have some code on the other side. That code is implementing the system model, but there is a kind of big conceptual gap between the artifacts. And by that, I mean that you cannot generate the code from the model entirely, because if you could, then you shouldn't kind of manually code at all. If you could generate the code, you should do that, and you shouldn't. Then you don't need to do consistency checks in principle, because you know that they are consistent by construction through the generation. Of course, you might have other artifacts too, but we focus on those highlighted modeling code. So the first thing is to benefit more from the models that you are creating, and by which I mean, okay, now what we need to do is we need to obtain elements of interest from the concrete elements through what I've called minors. But the point is that if we want to reason at the level of system components in the model, and for example system components in terms of the code, there's no such thing as system component in SysML, for example, or there's nothing like system component in the code. You need to define what it means. So you need to create a mapping from concrete elements in the artifacts to a conceptual element that you call in your domain system component. It can be whatever you call it, of course. So this kind of step can be done for any kind of element. Of course, you can even do it for unstructured things. You can even do it for like informal diagrams. But it is much easier to define these rules or these minors for models, because then you have a strict, let's say, semantics or a syntax that this model has, and so you can, you can much easier link things and get elements out of it and so on. And the point that it's like the lightweightness is kind of improved by you don't really need to create a complete mapping of the entire model to something else. You only just take out those elements that you are interested in. For example, a system component in the system model, it can be just boxes with a certain stereotype that we are interested in, and then you take those and you ignore whatever else is there. Okay, so now we see that those conceptual elements, we can capture them as let's say, a model element and code elements, and then we can start to define rules between them. So an instance of the consistency rule could be that, okay, we have system components in the model should be consistent with system components in the code. But so you can have the different types of things. For example, if you're talking about a system model in code, what you can say is, okay, for each system component in the model, there must be a repository in the code, and then for each state in the state machine, there must be a class on the other side in the code. And then when you have these two, what you might then want is a kind of hierarchy, because of course, if we say for every state machine, there should be a class in the code, we are not interested in just any class. We are only interested in those classes that are inside the repositories that we already matched. So there is a kind of hierarchy where first we have system component matched to a repository, and then within that system component, there are states defined in state machines that are defined in classes in the repositories in the code. So we don't really care about things beyond that. So you have these kind of elements in the top level that have kind of contained elements. And now what this kind of supports is that you can define the rules on the conceptual elements, and you can make use of the hierarchy that might exist in the models or in the code to limit, let's say, the scope of what you need to search. And if you are familiar with this kind of modeling technology or terminology, then now this starts looking a lot like this modeling stack. So on the bottom layer, we have M0, we have the concrete elements, let's say the real world things, and then we have a model on top and then a meta model on top of that. So here you see how you can benefit from more kind of treating things as models to introduce consistency checks between these different artifacts. And of course, now I show example with two artifacts, so the system model and code, but you can of course include many more things in this if you want. There's nothing stopping you from adding more things. So this framework that I present, of course, it has a limited focus. It does not include maybe kind of dream setting that I will get to later. What I'm thinking is the typical usage of this setting is that is that models are in a way ahead of the code. So you are creating those models to prescribe the implementation, the behavior that you want, and the structure that you want. And there is in a way a large conceptual gap between the model and the code, and this is filled by the software engineers that implement the ideas in the system model. But there's not it's not possible to generate the code from the system model, because the system model is not detailed to that level that would allow code generation. And the goal is then to provide insight into the consistency between these elements. The goal is not to ensure complete or to enforce complete consistency all the time, because this is kind of it would actually hinder you, because if you create a new iteration of the system model, of course you know that it is inconsistent with the implementation in the beginning, but then you allow, let's say, to catch up, right? So it's kind of useless to then immediately know this is inconsistent. Yeah, of course, I just added things in the system model. Now give me time to create it in the implementation. But the important thing is to monitor this and to know when you think that it's done, that it's actually done, and that the two are then actually consistent with each other. And so what I wanted to say about this kind of eventual dream scenario is that what I see in many kind of system engineering settings that people kind of want to go towards is a kind of setting where each domain works in their own favorite modeling tool. For example, you have engineers working in Simulink, and you have people working in this kind of CAD drawings, and you have system engineers making things in SysML and stuff. And then everything is magically connected to everything. And if you change something in the CAD model, it's propagated to the Simulink model, and so on. This is kind of dream scenario that is much further away, and I think it's not. It is not impossible. It's certainly kind of possible. There's a lot of challenges to go towards this, but you have to start somewhere. And what I think is good about this kind of approach is that creating these consistency checks in your current setting is already a kind of good exercise in reasoning about the development artifacts that you are creating, and making things a bit more formal, and reasoning about the links between them, what should be true, what should hold, so on. So now you think maybe this sounds quite simple. We can easily just define a few rules that say, okay, each state in the state machine must be a class in the code. Easy. Why would that be difficult? So I share some experiences of when I was doing this in companies to kind of indicate why maybe this is not super straightforward all the time. So in step 1, if you remember, it was about going from kind of informal artifacts to more defined artifacts. And what we want to do is agree on, if you, for example, want to say, to reason about the consistency of system components in the system model, then you have to agree on what that means. What is a system component? And so you have to align the different stakeholders on the semantics of currently maybe informal development artifacts. If you are working with diagrams, you have to decide what actually means a system component. And you might actually discover that across the different diagrams, different definitions were used by people, and then you have to kind of align this. So it's not always that you can start doing this straight out of the box. It might take some alignment. And then there's also another kind of alignment about the links between the artifacts and what they should mean. So when you are connecting them, what I was doing in the company was kind of following their own architectural guidelines that said, okay, we have decided that for each system component there should be a repository, and for each state there should be a class. But then when I started to implement this, then you start to encounter like the lists of exceptions to the rule. It's like, yeah, but for this component we actually do that we split it into separate repositories. Or for this component we merge them we create just folders inside a single repository, and so on. So just creating these links will give you some insight exactly into this. What should be the rule? What should be the guideline that you want to check? And then actually implementing these checks, I'm convinced that this is not the hard part. So once you have these steps 1 and 2 done, then implementing step 3 is reasonably straightforward. So you can create these minders in your favorite language. One tip is to persist an index of them, of the modeled, of the mined elements, so that you can faster rerun the rules. And another thing is the rule checking. You can again do it in your favorite language. You can even use constraint languages or so if you want to do that. But if you do it in general purpose language, probably you're already familiar with, and you can quite easily create this as well. So now you might wonder, okay, what can we get out of this if I actually do this? So the point is that you can get some insight into the structural consistency of the artifacts. And if we are thinking about system model and code, then I provided some sample. Of course, it's kind of redacted from the company. Although if someone would understand this, I would immediately hire them. If you just understand my system based on weird names, but still they don't usually like if I just present things. So I just redacted the names. But the point is, what we see is that we get some code elements out of it, and like inside the repository, we say, okay, what classes are there and what events are there in this repository, and then they are green or red based on if I could match this to something in the system model or not. And then in summary, like this yellow or orange ones are lighter or darker based on how much of the things inside are matched or not. And then in the bottom, what we can have also is some summary statistics of this.
What I'm working on now is to work also on some different visualizations of this. So what is now creating is some HTML file that is just a kind of report of the checks with this colored highlighting. But already this report now, it provides some insights for the company to improve traceability and impact analysis and so on, and simply the consistency management between the model and the code. And what you can even do, and what we are doing now, is to include these checks in the continuous integration pipeline, so that every time you submit, you build something, you can run these checks and see to what extent are they consistent, and then you can improve that next time. So in the end, what you get is a kind of quality metric, not for a single artifact, like you have maybe for code, but it's a metric for the quality in a way of the links between the artifacts, of the consistency between the artifacts. And this could be interesting for like software engineers or system engineers, but also for maybe for management and so on. So in summary, you are probably doing some kind of model-based development, and you might aim towards short development cycles in this. And then what becomes of interest is to monitor the consistency between the artifacts. And what we presented now is steps towards achieving this, and to create a kind of lightweight framework for creating these consistency checks. And we think this can help to provide insight into the meaning of the development artifacts, the relationship between them, and monitor their consistency. And it might feel like a bit obvious things, like you find, since you aim for finding the structural consistency, you might find kind of trivial things like some naming is not consistently used across different artifacts. But this is actually exactly what you're interested in finding, because later, if you want to kind of continue analyze the system, or maybe bring in new people to the project, this is exactly things that are hard to understand if you don't have this kind of consistent mapping. So thank you for your attention. If you have questions now, I think we have some minutes now to discuss, and otherwise you can always contact me or Jan after the talk to discuss something.